Let's have a look at a very simple example. We have a diary and a calendar system. Our clients tell us that they have a number of mobile phone applications, each of which need a diary and a calendar. So our job is to design a diary system that allows anybody to set up an event at a particular time on a particular day. The diary system has events, it should have calendars, and it should interface to the internet so that we can actually work out what the current day is and what the current time is. So, what is the design? When faced with a problem like this, we can start to come up with some ideas. Let's have a calendar object. Well, we might need to get the current time, so let's have a current time method. We'll need to store events. Well, we'll get events, so we'll have an event class, and events will actually consist of some description, some text. So we'll actually have a text class, and that must be a part of the event class. But this is a relatively unstructured method, and if we keep going in this way, how can we be sure that we meet all of the requirements, meet all of the constraints, and solve the original problem? This brings us to another really important aspect about design problems. They are often underdetermined, and they're underdetermined in the following way. There is no clear logical path from the statement of needs, the statement of requirements, to a solution. How do we get from I want a diary and a calendar system to any particular design structure like the one that we hypothesized earlier? Looking at the design problem a little bit deeper, we can see, well, we find that often the requirements description is incomplete. We don't have all the information that we need. We don't have all the details. What are the interfaces that the diary must use? How do people want their text presented? We often have to go back and look over the requirements very, very carefully. But even worse, the people who did the requirements may have missed something. We don't have all the information. Requirements descriptions are incomplete. The other problem that we typically face when we're looking at a design problem is that the requirements and the design come from completely different conceptual worlds. Requirements are often focused outside. They look at describing what's actually there. They want to take into account the needs, the feelings, the desires of the stakeholders. Designs are technical. Designs deal with data structures. Designs deal with the way that the system must respond to meet the needs. And if we look at these two things together, the fact that the requirements are incomplete and that requirements and design come from completely different conceptual worlds, then the problem of solving the design problem often requires leaps of creativity. So, how do designers and software engineers move from requirements to a design? To make sure that they get all of the needs and all of the constraints satisfied in their design, they often do this in a systematic way, or where possible they do it in a systematic way. That systematic way doesn't mean that there is a clear and fixed algorithm for every step. It just gives you a guide as to how to structure your thinking in order to take the best way from requirements to design. For example, most modern design methods, object-oriented design methods, advocate the use of use cases as a first good step. This is an example of a use case diagram. Each of the bubbles represents a task that the stakeholder, in this case the client software, called an actor, will need to undertake. In our use case diagram, we've chosen a number of different activities that our diary and calendar must take. Creating a new diary, creating a new calendar, deleting a calendar, updating a calendar, deleting an event, and so on. So when we start breaking the system down into these kinds of interactions and these kinds of tasks, yes, we're doing analysis, but we're already starting to do design. When we look at the tasks in detail, they will each involve a sequence of steps that the client software will do with our diary and calendar software, and we can take those steps and break them down further until we know how to implement them. And this is the essence of most modern design methods. Start with requirements and keep breaking things down until you can see how to implement them. In this subject, we'll be using object-oriented methods mostly. They use models, abstract artifacts or abstract notations to try and capture requirements and to develop designs. Object-oriented methods try and bridge the gap between requirements and design by bringing the conceptual world of requirements and design closer together using the same notation. But be warned, there is still a lot of creativity to do and choices to make along the design path.